Welcome to today's webinar. Glad you could join us. The webinar today will cover the map target function in the Vertex Laser Geo in the Laser Geo and the map trail function. And the map target function we will talk about today will be to when you want to know how many acres or how many hectares is an area, like could be a clear cut or it could be a parking lot or anything that you're interested to know how big this area is. And the map trail function to log a road in the forest or a road anywhere, a path, just to make a track log using the sensors in the Vertex Laser instead of just as a regular GPS logging where you go. First of all, we will cover the menu function briefly, and then we will go deeper into these functions, map target and map trail. So here we go. So the Vertex Laser Geo and the Laser Geo, they have some sensors built in that I just will talk about quick. And we have the orange unit you see there. That is the Vertex Laser. That's the combination that has both ultrasound and laser. And then you have the blue unit that uses only laser to measure distances. Both these units are the same if you so the only difference is that the Vertex Lasers has ultrasound. There is a tilt sensor built in, and this tilt sensor is accurate. It's 0.1 degree, and we use that in all the measurements in the background. For example, if you measure a distance, we also measure the angle to capture the horizontal distance to the target. So the tilt sensor is very central in the unit when measuring trees and all heights and things like that. Then we have a long-range precision laser. It measures from 50 centimeters up to 600 meters with an accuracy of plus/minus 4 centimeters. Then the Vertex Laser, the orange unit, has ultrasound. And ultrasound is very good when measuring in dense areas and forested areas. When you cannot clearly see the target, then you should use ultrasound. And then you measure with a transponder, what we call the T3 transponder, and you measure the speed of sound instead of using the laser. Then you have a compass sensor built in the unit, and this compass sensor is accurate plus/minus 1.5 degree. You can show both 360 and 400 gone in the unit. The compass can be calibrated by you as a user. We make a factory calibration here, but you can calibrate it yourself, important to know. Most cases, it's only a test that needs to be done, so you make sure that the compass works in the environment where you are, or you don't have anything that disturbs the compass, and there is a test function for that. Then you don't calibrate the unit. Then there is a built-in GPS receiver, and that's a standard GPS receiver, 1 to 3 meter accurate, but you can also connect the unit to external GPS that has a better precision by Bluetooth. So you could connect to, for example, a sub-meter GPS if you were interested in getting a better precision in your location where you are standing in relation to the target. Then you have a built-in SSD drive, so all your measurements can actually be stored internally in the unit. So if you have checkboxed in the settings menu that you would like to store all your measurements in the unit, you will send each measurement to the SSD drive. Then there is Bluetooth 4.0, so it's a long-range Bluetooth. We made testing, and it has not been any problem sending data 50 meters. If you remember the older type Bluetooth, it's in room environment, and many times it's out in the forest. It can be hard to send data 5 meters, for example, but this is working very good and secure and easy to connect to other devices as well. You have a USB. So the USB port in the unit is used to communicate with the, let's say you come to the sending your measurements to the PC, and you can also use the USB to upgrade when we come with a new software version, for example. The USB is also used to charge the unit. It has a Li-ion battery and it's rechargeable, and the time to charge the unit from zero empty until a full charge is 3.5 hours if you charge it in the wall plug. You can also charge it in the car with a car charger, or you can use what we call an emergency charger if you have that you can bring with you and you charge it while you're measuring. Then you have the graphic LCD display that we also have on the Vertex 4 for those of you who are familiar with that unit, and it's a very visible graphical display where you can see your results and what menu you are in and so on. And it has a heads-up LED display. It's an OLED display, and we have a yellow OLED now since more than 1 year, and that is very visible even in direct sunlight, and you will see your measuring results directly in the scope. This is a big advantage, not only that you see the results, but in many times when you're measuring targets that are hard to capture, for example, a power line, you will immediately see if you have the correct target or not directly in the scope, and you don't have to take down the unit and look on the side. So that was the sensors, and then we have the different functions, and the 1-point laser, that is a function that is used when you are interested to know the difference in height between you and the target. So if you are on the same level as the target, it will be the correct height, but it will actually present the difference in height between you and the targets. For example, measuring a tree. So if you measure on the top, it will calculate from your eyes the height difference. And then you can set the eye height in the unit, and it will add that to the height that is calculated. We have the 3-point. And 3-point is the one that we recommend mostly in forested areas, and it will measure the actual target height. So if you measure a tree, it will be the height of the tree where the tree is standing, no matter if it's in a slope or if it's on a hill in relation to you. Then you have the 3D vector function, and the 3D vector actually gives you all the vectors of a target. It could be measuring the green crown width of a tree, for example. You can measure how wide is the tree crown, and it will give you all the different vectors. Then you have the function height DME, and that is the height function using ultrasound in the unit. So this function is only available in the Vertex Laser. And this is, of course, very handy when you work in forested areas. Whenever you cannot clearly see the target, then use the DME. But there is the limit is that it's up to 30 meters. Then you have the built-in compass, and as I mentioned, the compass can be set to show 360 degrees or 400 gone. And it will show you the compass bearing in the scope and on the side of the unit when you select that function. Then you have the angle measuring, and it will bring up the tilt sensor in the display, and this is just when you want to know the slope. For example, if you are planning to build a road or you want to know a slope in the terrain, you use the angle function. Map target we will cover more deeper, and map trail as well today. Then we have the line clear function for the power line business, and the line clear function is used to know if a tree will fall on a line. It could be a power line, a telecom line, or you can also use that function if you're going to fell a tree in your yard to know where the tree will actually fall before it damages your house or something like that. A new function in line clear menu, it's an under function in line clear, is also to know if a branch is nearby the power line, if it will be dangerous to create, for example, a fire if the power or the voltage would be too high and will go over to that tree. So we can actually measure how close the branch is to the line, and that is an under function in line clear. Then we have the delta height, and the delta height is to know from a straight line between the power line poles down to the maximum sag, or how much the line is hanging down. It's a power line function as well. Okay, so that was the general introduction of the unit. So now we jump into the two functions that we will cover more deeper today, and that is first the map target. Here we're interested to measure an area, and normally you would use a GPS and you would walk around that area if it's a clear-cutted area, or if it's a stand, or if it's a parking lot, and the GPS will record that for you, but you have to walk around. In this case, I will show a short film. You will see this is the area that we need to capture, and we need to record it and to be able to show it on our computer where we have been and how big this area is. So instead of walking around here, you're standing somewhere central in that stand on the clear cut, where you can cover all that area from one position instead of walking around. So you use the map target function and the sensors in the unit, and you record all your shots around, and then it will create a file, what you see here on the film as well. It will create a CSV file, and here in this case a KML file, and you will see, but you have only stood on one position rather than having to walk around. And this could be very good as well. Let's say you have a small stream, or you have a road crossing in the middle, then you cannot go to the other side because it will be very time consuming. Then you can stand on one side instead and measure everything if you can see it. So to explain that more deeper, what was done in the film, you walk and stand on one position, as I said, and then you start on the map target and you select map target, and then you on your first position it will start a GPS to know where is my location, and to capture one GPS position. It's not needed to have a GPS position, but if you don't take the GPS position, you cannot show where in the world is this surface. So it's important to take one position to create that KML file. Then you measure and store positions as much as you want. In this case, it's maybe 15 different locations in this stand, and then it will create the file for you and calculate how many acres or how many square meters or how many hectares is this. That was the map target function using the laser. Then if you have a more complicated area, like in this case, you cannot be at one place and cover all that area with the laser, because you cannot see all this area. This is a very good function. So in this case, you will walk to one part where you can cover, let's say, most of that part, and you record first your GPS position, and you measure that part and store your laser positions. Then you select a new reference point, and you can move to that. You see the blue line. You go to that. It could be a stone, a rock, or whatever you see clearly, and you use the sensor, the laser in the unit, to move to a new reference point, and you continue to measure from that point. Then you move again to a new reference point and you measure there. And now the unit will add to the same file these 3 measurement points, because it knows that you have moved to new locations. And this could be very handy if you, for example, if you have something crossing your stand or that you cannot measure from that position, you just move. You can just as well use the GPS to move to your new location. But remember, then it's the accuracy of your new reference point is depending on what GPS receiver you're using. If you use the laser and you have a clear target, you will have a very high precision in your new reference point and a very good accuracy. Okay, so then we have the third option here. That is, if you want to use the Vertex Laser Geo or the Laser Geo just to GPS your area, to make a track log, just like a normal track log. Then you select that function GPS area that is under the map target, and you will start that function, and it will start to log positions as you walk around. But now you have to walk around the whole area, and it will store a position every 5 meters you are walking. And if you have a position, let's say you have a bend of 90 degrees where you're gonna walk in a totally other direction, but you have no point there. If you press the on button, then it will force a position at that point to make one more, not only the 5 meter positions, it will make one manual positions. You can also add more positions yourself, improving the accuracy of your surface. But that works as a normal GPS track log. Then there is a function that we specially developed. So if the previous function mentioned you only store one GPS position, and all your measurements are actually using that position. In this case, it's to measure differences, for example, in the surface of a river. How big is the elevation from different places? And if you're measuring from one end of the stream to the other end, and then you're going to measure a new position 5 meters down, but you have branches in the way, so you cannot stand on the exact same position. In this function, map GPS, you have a new GPS position for each measurement that you do with the laser. So you store not only the new target position, you also store a new target for your position for each measurement. Otherwise, if you measure with other functions, it will assume that you're standing on the same place all the time. So there is only one position of your location. But in this case, it will be a new target position and a new position for where you're standing to measure. Could be in research or whenever you want to know things like that, you can use this function. Maybe you come up with ideas where it could be used. Okay, then we have the map trail. So what I mentioned now was all under the map target function. Now we have the map trail function, and here it's, as I said, to measure. It could be a skidder road in the forest, could be a new road that you want to build, or a bike trail, or anything that you need to record very accurate. So how this works. Yeah, okay, so how this works is actually, so now my first measurement, I need to store the GPS position, of course. So when I select map trail and I press on, it will take my position first with the GPS, and that is the only GPS position that will be taken. All the other points is with the sensors. So here is, for example, mapping a forest road and how that could be done. So you select map trail and you log your position with the GPS first, and then you measure with the laser and the compass and the tilt sensor your next position. It could be a stone or a tree or anything that you see clearly. Then you send that to the memory. You go to that position and you measure your next point. You send that to the memory and so on, and it creates a CSV file and a KML file that you could use for further processing or sending to someone that needs this data. Then you have, for example, an example of how this can be used. For example, if you're going to do a clear cutting and you go out for planning purposes and sending it to the harvester driver, for example, before harvesting this area, it could be that you have some parts where you don't want to drive because you have a stream or something crossing, and you want clearly to guide how the driver should drive. So then the map trail function is used. In this case, you log that beforehand, and it will create a trail with a start point and an end point looking like this pretty much. That could be very useful to send, and in that case the driver will know exactly how he should drive to cut down the trees. And of course it can be used in many different areas, but that is to give one example. So this was it for today, and thank you very much for listening. Hope it was interesting and that you learned something new and you could use it and maybe give us more ideas. That will be. It's always interesting to hear what comes up, but I think it's many possibilities with the Geo unit, and probably we have many more to discover as well. Thank you very much, and hope you have a great rest of the day. Thank you.